about how you're doing, how you feel. I care about you guys. I want you to feel good. Okay? Same thing's going to be in 1050. Okay, here we go with lesson 18. Okay, we're going to start doing logs. And we're going to do logs for a couple of weeks. Okay? Who says, I hate logs? I do not like logs. I do not understand logs. Okay, listen. I used to be a hater too. I used to say, I hate logs. I don't like them. They're weird. They don't make sense. I'm telling you guys, this is all you have to do. You have to memorize the rules and use the rules. That's all you have to do. Just memorize those rules. Okay? Okay, so this is an exponential function. This right here. This is y equals b to the x power. The reason it's an exponential is because you have a variable in the exponent. Okay? Here is a graph of an exponential equation. Grab your pencil and dash your line right there. That is called an asymptote. Every person in this room, tell me what axis that red line crossed. Does it cross the x or does it cross the y? Crosses the y, right? So it's going to be y equals. Where does it cross the y-axis? At 0. So there's the equation for your asymptote. Okay? Okay, everybody look at the graph and we're going to figure out what the domain is of the graph. Remember, domain is x. Start small. So if I'm clear over there, I would just go up a teeny bit to hit the graph. Everything hits it. What if I'm really far to the right? Will I ever hit the graph? Yes or no? If I'm clear over here and I go up or down forever, will I ever hit that graph? Yes or no?
Yes.
I will. I just have to go where? Really high up. Okay, so the domain of that graph is everything, all real numbers. Okay, range is y. Start low. Guys, look, here you are low on the graph. You move up and you get up to a 0. That graph never touches 0, but it touches everything above a 0. Okay, so we're going to go 0 to infinity. Tell me how to close my 0. Is it a bracket or is it a parenthesis? It's a parenthesis. Why not a bracket? It never touches it. If it actually touches it, it would be a bracket. Okay? You guys see this point right here? That point is present on every parent exponential. So the y-intercept is 0, 1. Okay? This is if b is greater than 0, like 2 to the x or 7 to the x or even 1.2 to the x. So the growth factor is the b. Okay? Now, I want you to look at this and I want you to write the word parent. A parent graph means there are no adjustments to it. Everybody look right here for a second. Y equals 4, you don't have to write it down if you don't want to the x minus 1 minus 3. That is not a parent graph. The reason it's not a parent graph is because you've got an adjustment here, you've got an adjustment here. It's not just the base and the exponent. If you do have a parent graph and it's an exponential, here are 3 things that you need to know. You need to know that you have an asymptote at y equals 0. It always is going to hit the point 0, 1, and it's always going to hit the point 1, b. Literally, that's what you have to remember about graphing an exponential. So guys, look at this graph right here. If I go right 1, I went up 2. So I know that my b must be 2. So the equation that goes along with that graph is y equals 2 to the x, because I went right 1, up 2. So my base must be 2. Okay? Who says I understand what you're saying to me? Raise your hand. Give me some feedback. Okay, let's do this one. Y equals 2 to the x power. You guys see the table? I think the table is really silly. Okay? To the side of 2 to the x, I want you to write the word parent. There's no +1 or -3 or no negative sitting out there. So literally, you guys, you can graph this thing in like 15 seconds. Okay? Look what you do. I know I have an asymptote right there. I know it hits the point 0, 1. Put your pencil at the origin, you go right 1, and then you go up whatever the base is, which is 2. You draw in your graph, and you're done. That's all you have to do, just those 3 things. Okay? What is the domain? Everybody look at that graph, and I want all 25 of you to tell me what the domain is. What is it, you guys? It's everything. Good. All real numbers. What is the growth factor? Can you tell me that? It is a 2 because that's your base. The asymptote, if it's a parent, is always just going to be y equals 0. Okay? Now, if I'm not going to give you a table, I don't think they're going to give you a table. But if they do give you a table, we better know how to deal with it. So let's fill out a few tables, and then I think we just probably won't do tables anymore. Because it wasn't necessary. The point of the table is to help your graph. I just graphed it, and I didn't even use a table. Okay? If x is a 0, 2 to the 0 is a 1. If x is a 1, 2 to the first is a 2. 2 to the second is a 4. Can you guys tell me what 2 to the negative first power is? What's that? It is 1/2. What is 2 to the negative second power? Can you tell me that? It is 1/4. Yeah, that's it. Okay, the next one is 2.3 to the x power. Okay, so I'm going to rewrite the equation right there just so you guys can see it. So look what you do. You go, okay, it's a parent graph. So I know I have an asymptote right there. I know I'm going to hit the point 0, 1. I know if I go right 1, I go up 2.3, curve in my graph, and I'm done. That's it. That's how quick you do it. It's not a race, but I'm just telling you it's so quick and easy to graph these things. Everybody in the room, what is the domain? Everything, right? Tell me the growth factor. 2.3, and the asymptote is always going to be the same because these are all parents, and that is y equals 0. Okay, who says this is easy? Raise your hand, let me see how you're feeling. Great. Okay, let's fill in the table. 2.3 to the 0, that's a 1. 2.3 to the first, that's 2.3. 2.3 to the negative first, that's 1 over, what is it? 2.3. Now I'm just going to leave it like that. I'm not even going to use it. This one right here is 2.3 to the negative second. So I'm going to write 1 over 2.3 squared. That's it. It's good enough for me because I don't think the table is even necessary. Okay? Y equals 3 to the x power. Okay? Look how easy. It's a parent graph. So I know I have an asymptote right there at y equals 0. I know I'm going to hit the point 0, 1. I put my pencil at the origin, I go right 1, up 3, draw it in, there's my graph. Okay, domain, everybody in the room, tell me what is it? Everything. Growth factor, talk to me. 3, asymptote, y equals 0. This is a breeze. All of you haters that raised your hand and said I hated logs, it's going to be that easy if you just stick with me. Okay, let's do the table really fast. 3 to the 0 is a 1. 3 to the first is a 3. You guys, what's 3 to the negative first? 1/3. Yep, 1/3. Okay, here we go. Now this one looks different. Look, you guys. It's still the same equation, b to the x, but look at the graph. Now it's swinging the other direction. Take your pencil and dash in an asymptote. Okay. The reason that it swings the other way is this right here, guys. The value of b is less than 1. It's small. So it'd be like 1/2 to the x power, or 1/3 to the x power, or 0.1 to the x power. So that base is smaller than 1. Okay. So look at the asymptote we just drew in. What axis does that red line cross? Y. Where does it cross the y-axis? 0. Okay. What's the domain? Look at the graph, everybody. Tell me. It's still everything, right? Look at the range. What is it? Is the range everything? Start low. Come up. What's the smallest one? A 0, but it doesn't hit it. So the range is still 0 to infinity. You guys, look at that point, 0, 1. It's still there. Come over here and I want you to write 0, 1. And I want you to write y equals 0. So the y-intercept is 0, 1. The growth factor is still b. And then look what you do. You go right 1, up b. So these requirements are exactly the same as the other one. Those three things that you have to remember. Look right here, everybody. I went right one, and it looks like I went up about, what does it look like? About a half. So everybody go y equals, in parentheses, 1/2 to the x power, like that. Okay? 2 seconds, very quick conversation. Weber State had me grade your midterms so strictly. A lot of all or nothings. Look at what I've written right here. Y equals 1/2 to the x, no parenthesis. Y equals 1/2 to the x with parentheses. I need to know the difference. What is the difference? Go ahead.
Well, the one on the left, it looks like the exponent is with the 1 and not the 1/2.
Yes, you're exactly right.
It would be 1/2.
It is. You're exactly right. So this is 1 to the x over 2. Everybody write that down. But 1 to any power is always 1. So she went even further and said it's always just going to be 1/2. And you're exactly right. This one means 1 to the x and the 2 to the x. It means they're both raised to the x power. Okay? All right, so let's come over here. Guys, listen to me for a second. You don't have to do this. Listen, you don't have to say, oh, well, 1/2 is smaller than 1, so I know it's going to swing the other way. You don't have to do that, okay? Look what you do. You say 1/2 to the x power is a parent graph. So I'm going to grab my pencil, and I'm going to dash in an asymptote. I know it's going to hit the point 0, 1, so I'm going to put it right there. Now, everybody watch this, okay? I'm going to go right 1, and I'm going to go up whatever my base is, which is 1/2. Everybody freeze right there. Then you go, well, that's weird, because it's lower. And then you're like, oh yeah, if it's lower, it's going to just be higher on the other end. Look what you do. Your base is 1/2. Flip that upside down. You get 2 over 1. On the other side, when you go to a -1, that's how high up you go. You go up to a 2, and you swing it over. I'm going to explain why you do that in just a second. Okay, so that's it. What's the domain? Everybody in the room, just shout that out. Everything. Good. What's your range? 0 to infinity. 0 with a parenthesis. What's your growth factor? 1/2. Actually, it's not a growth factor. Cross out the word growth. What is it? Do you know? It's called a decay factor. Yep, because it's smaller than 1. The asymptote is still the same. It's still just y equals 0. The y-intercept is still the same. It is 0, 1. How about the x-intercept? What is that? There is none, right? So none. The last question. For what values of x is the graph increasing? Everybody look right here for 2 seconds. Okay? So you start small. Everybody look right here. You start small when you do this on the x's. So if the x's are small, the blue graph would be up here. And you travel from left to right. Everybody tell me, what's my graph doing right here? Increasing, decreasing, or constant? Talk to me. Decreasing. So the question is, where is it increasing? What's the answer, everybody? Nowhere. Okay, so we're going to say never. For what x values? We're going to say none would be grammatically correct. Okay, let's do the table. 1/2 in parentheses raised to the 0 power is a 1. 1/2 in parentheses raised to the first power is 1/2. There's your table. Okay, next one. It's a parent graph. I have an asymptote right here at y equals 0. It definitely hits the point 0, 1. If I go right 1, I go up 2/3. That's 0.6 repeating. So then I go, well, that's weird because it's low. And I go, oh yeah, if I take that 2/3, flip it upside down, I get 3/2. That's how high up I go on the other side. So if I go left 1, I go up 1.5. Just curve it in, looks like that. Got it. I told you I was going to explain why we flip it upside down, but I didn't, so I'm going to do that on this one. Okay, the domain, what is it? Just shout it, guys. Everything. What's the range? 0 to infinity. Anybody besides Harrison? Growth factor? It actually is a decay. Cross it out and put decay. What is it, everybody? 25 of you. 2/3. Asymptote. What is it? Y equals 0. X-intercept. None. Y-intercept. 0, 1. Where is it increasing? Never. What if it said decreasing? Everybody add the word right here. Decreasing. Where is it decreasing? Tell me that. Always. How do you say always in decreasing? Can't say all real numbers. It's from negative infinity, yes, to positive infinity. Good. Okay. Okay, I want to explain something. Put a negative right here. Okay. So you have 2/3 to the 0 power, that's a 1. What if you had, in parentheses, 2/3 to the negative first? Okay, watch this. You'd have 2 to the negative first over 3 to the negative first. But you can't have negative exponents. So that'd be a 3 to the positive first on the top, a 2 to the positive first on the bottom. That's why on the other side, when you go left 1, you flip it upside down. Because that negative 1 tells you just flip that guy upside down. Who says I understand what you're saying? Raise your hand. Okay, good. Let's do this one. Y equals 0.75x. It's a parent graph. There's my asymptote. It's definitely going to hit the 0.01. If I go right 1, I go up 0.75. What is 0.75 as a decimal? What is 0.75 as a fraction? 3/4. Happy Halloween, by the way. Is anybody doing anything fun tonight? Is anybody going trick-or-treating? If you went trick-or-treating to my house, I would give you candy. Because you're not getting in trouble. You're just getting candy. Flip it upside down, 4/3. That's 1 1/3. Go left 1, go up 1 1/3, draw it in. There's your answer. Okay? Domain. Here we go, guys. Domain, everything. Range, 0 to infinity. Growth factor, cross out growth and put the word decay. Why is it decay and not growth? Less than 1, right? 0.75. Asymptote, y equals 0. X-intercept, none. Y-intercept, 0, 1. Where is it increasing? Look at the graph. Tell me. None. Yeah. None. Let's do the table. 0.75 to the 0 power is 1. 0.75 to the first power is 0.75. Done. Who says this is easy? Raise your hand. See? Told you. Told you, told you. Okay. This is important and sometimes not so easy. Okay? Shh. Hey, guys over there, you 4, you 3, look right here. If I'm teaching, no talking. Okay? Please? Thank you. Okay. Look at the table. Is it linear or is it exponential? Okay? Look right here. X's, up by 1, up by 1, up by 1, up by 1. Y's. What do I add to 7 to get 11? 4. Is 11 plus 4 15? Yes. 15 plus 4 is 19? Yes. 19 plus 4 is 23? Yes. Is it linear or exponential? It's linear. Okay. If it's linear, determine the slope. Okay. Everybody do this. Everybody put 0, 7, 1, 11. Y's go on top. So that's m equals 11 minus 7 over 1 minus 0. That's 4 over 1, which is a 4. Okay? That's one way to do it. Another way to do it is this. It's y's over x's. What's the change in the y? 4. What's the change in the x? 1. 4 over 1 is still a 4. Okay? Write an equation that shows a relationship. Everybody write down y equals mx plus b. M is the slope. So that'd be y equals 4x. Now the b is the y-intercept. Everybody write that down. The b is the y-intercept. To find a y-intercept, you let what be a what? Do you remember? Not the y. If you're finding y, you let the x, right? So you let the x be a 0. Look at the table. I've got it. If x is 0, y is 7. So this is going to be a plus 7, and you're done. Who says gotcha? Okay, great. Question 4. Look right here. Add 1. add 1, add 1, add 1. Look right here. 2 plus 2 is 4. Is 4 plus 2 8? No. So this is not what? It's not linear. It's got to be exponential. Okay? If it's exponential, determine the growth factor. Well, that's what you're multiplying by. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So the growth factor is 2. Write an equation. Everybody write down y equals a times b to the x power. Now this is the first time you've seen this. Sometimes there's a number in front. Let me give you an example. You don't have to write this down. Y equals 3 times 2 to the x power. Sometimes the number in front is not a 1. Okay, so we know that our b is a 2. So that would be y equals 2 to the x power. Okay, now we have to see if that works out. If x is a 1, you get a 2. Is 2 to the first 2? Yeah. If x is a 2, you get a 4. 2 squared is 4. 2 to the third is an 8. So it totally works out. The value of a in this problem is what? Can you tell me what it is? It's 1. Good. You guys are so smart. It's not always going to be 1. Okay. Here's example 5. Someone tell me what time the bell rings, would you please? What time? 04? Oh, we're good. We're good. I want to see how close we are. Yeah, we're good. We're cruising. Okay, here we go with question 5. Okay, I want to give you your midterms back so you can take pictures of those. Okay, what do I add to 0 to get 1? 1. 1 to get 2, plus 1, plus 1, plus 1. Okay, what do I add to 4 to get 0.4? 0.4. Is 4.4 plus 0.4 4.84? No. So it is exponential. Okay. Now, I'm going to skip to part C. What am I multiplying by? Okay. What's my growth factor? I'm going to actually put the word growth factor. How do I know that it's a growth factor, you guys, and not a decay? The numbers are getting bigger. That means growing. Look what you do. Take this 4.4, write it down, put it over the y value before that, which is a 4. So if you just go 4.4 divided by 4, you get 1.1. If I wanted to do this one, I would go 4.84 divided by 4.4, and I still get 1.1. So it doesn't matter which 2 I choose. I write down 1, and I divide it by the previous y value. Okay? Grab your calculators. Everybody go 4.84 times 1.1, and you get 5.324. Take that and times it by 1.1, and you get 5.8564. So now my table is filled in. That was part B. So I did C, and then I went back to B. Write the equation that explains the relationship between the two variables. Everybody write y equals a times b to the x power. I know that b is 1.1, so it's going to be 1.1 to the x power. Now, there might be a value of a other than 1, so let's check. If x is a 0, you get a 4. Is 1.1 to the 0 power, is that equal to 4? No. I cannot do this. I can't add 4 because that's not exponential. Okay? So what do I do to a 1 to turn it into a 4 actually it would be plus 3, right? Anyway, what do I do to a 1 to turn it into a 4? Multiply it by 4. So put a 4 in front. Okay? Put a 4 here. And then now let's check if that's it. So if x is a 0, 1.1 to the 0 is a 1, 1 times 4 is a 4. If x is a 1, 1.1 to the first is 1.1, times 4 is 4.4. Let's all try 2. Grab your calculators. Go 4 parenthesis, 1.1, close it off, hit x squared, hit enter, 4.84. We got our equation. So don't just write it down and not check it. You've got to make sure that you're good. Okay? Okay, question 6. This is going to start getting more difficult. 6, 7, 8, and then we are done, I think. Yeah, 6, 7, 8. Okay, here's 6. This is important, so I need you to listen, okay? The value of a vehicle is a function of the age in years, so it's like a car. The value of the vehicle models this equation. Answer the following, okay? First of all, I want you to write this down. Everybody go f of x equals a times b to the x power. Draw an arrow to that a right there, and that is the starting value. You know how I know it's a starting value, guys? Look, if x was a 0, b to the 0 was a 1, 1 times a is a. So when you start, your x is a 0, and your value is an a. Who says I gotcha? Let me see. Great. Look at this right here. 0.92. Is the value of the vehicle going up, or is the value of the vehicle going down? It's going down, okay? You take the value and you multiply it by 0.92, the first year. What does that mean? If you start with 25,000, everybody write, everybody do this, xy, then go 0, 25,000, and then do a 1, okay? Let's go 25,000, parenthesis, 0.92, close it, raise it to the first power, okay? And then hit enter, and you get 23,000. That's what I got. Is that what you got? 23,000? I want to know how you figured that out. Like, I don't want you to tell me 0.92 to the first power. I don't want you to say that. How much did the value go down? 2,000 bucks. How do you figure that out? What does this 0.92 mean? Somebody talk to me. Okay, this row right here, talk to the person beside you. This person right here, talk to the person beside you. You join them. This row talks to this row. You talk to each other. You got a minute. Go. What is it? How do you figure it out? What does the 0.92 mean? Talk to each other. I should hear talking. Okay, right or wrong? The value of the original vehicle goes down 92% the first year. That's very wrong. That'd be like almost gone, right? Almost 100. It doesn't go down 92%. It goes down, tell me. What is it? 8%. It goes down 8%. It's 92 of what it was before, so it goes down 8%. The next year it goes down another 8%. The next year another 8%. Who says I understand that? Raise your hand. Okay. So, what is the purchase price of the vehicle? Everybody talk to me about that. 25,000. It's the initial purchase price. What is the growth factor or the decay factor? Guys, is it growth or is it decay? It's decay. And what does it mean? 0.92. Now you have to explain it. Okay? This is what I'm going to say. Every year, the value I'm going to try to say the 92. Every year, 92% of the previous value remains. Every year, 92% of the previous year's value, maybe put year's value, remains. Okay, what will the value be in 3 years? Everybody go, V of 3 is equal to 25,000 times 0.92 to the third power. I want you to remember this is money. There was a problem like this on the midterm, and if you didn't round it to the nearest cent, you lost every point, because you have to think about the fact that it's money. So it's $19,467.20, and your label is a dollar sign, which goes in front of the number. Okay, now that graph that's right there is silly, so we're going to go like this, okay, and I'm going to go, so it's 25,000 and it goes down, so I'm going to go 5,000, 10, 15, 20, 25, and this is value in thousands, okay, and then I'm going to go 1, and then 2, and then 3, and then, you know, it would go out for a long time. I'm kind of going far, and I'll tell you why in a second. So initially, 25,000. After 1 year, 23,000. After 3 years, 19,000. Okay? Is this a line? Is it a line? Talk to me. A straight line. What is it? Exponential decay. So it's actually going to go like this. Right? You have an asymptote. The asymptote is here. Why does it never touch the x-axis? Don't tell me about asymptote. Talk to me about cars. You can't have a negative value. That's a beautiful thing. What about a zero value? Even if your car won't start, you still have tires, and you have metal, and you have a seat, and you have a steering wheel, and I bet that those things have value in a junkyard, right? Okay, here's the next one. Question 7. Your starting salary for a job is $30,000 a year. You have 2 options for pay increase. One is $2,000 every year. One of them is 3.5% per year. I want you to write the words linear, and I want you to write the word exponential. Okay? One of these is linear. The other one is exponential. Someone tell me which is which, please. Say what? This is exponential, and this is linear. Yes. If they give it to you as a percentage, this is important. If they give it to you as a percentage of increase or decrease, that is exponential. If they just give you a number that's supposed to be added or subtracted, that's linear. Okay? Now they want the equations. Everybody draw a line like this. And I want you to go plan A, and I want you to go plan B. Do you see how I'm clearly labeling everything? Okay? So they want the salary, S equals, in terms of X years. So you start at $30,000, and then every year that passes, you make $2,000 more dollars. How do I write that down? Linear. How do I do that? What do I put right here after my 30,000? I'm going to put a plus, not times X, because that'll mean 30,000 and then 60,000 and 90,000. That's not what's happening. Okay? Go ahead. Plus 2,000x. Yes. Yep, and you could go 2,000x plus 30,000. That's fine. Yep. Okay. How about this one? Salary equals. Remember, the number that you start with goes right at the front. So what did we start with? 30,000. And then increase 3.5%. You guys, 3.5% is 0.035. Raised to the x power. Grab your calculator. Let's put in a 1. Everybody do this. 30,000, parenthesis, 0.035, close it, raise it to the first, enter. That means after 1 year, you're going to make $1,050 a year. That's not right. What do I have to do? You can't, you could, but you can't do it to this guy because this guy's supposed to be exponential. So you can't put plus right there because then it's not exponential anymore. So what do we have to change? Look at the numbers. 30,000 0.035 and x. Which one do you think we change? It's the 0.035. Look what you do. Increase. Okay? Increase. If it's increasing, you have, write this down. Increase. You have to go 1 point. And then in here goes the percentage of increase. Why do you have to have a 1 in there? Because the 1 is going to keep the 30,000 as part of it. And then the 0.035 incorporates the raise. So 1 times 30,000 brings in the 30,000. The 0.035 pulls in the raise. Who says gotcha? Let me see. Okay, great. Question 8. You wanted to purchase a car that's $32,000, but you can't afford it. Every year that passes, the car increases by 4.5%. Is this linear or is this exponential? That's the first thing I want you to answer. Exponential. Everybody write down the word exponential. Okay? And then I want you to write y equals a times b to the x power. Write an equation that projects the cost t years given that it costs $32,000 right now. Okay, so everybody write cost equals, what are you going to write at the very beginning of that equation? Talk to me. 32,000. 4.5% is 0.045, but it's increasing. So what's my base? 1.045 raised to the x power. There's your equation. Okay. Does it have a growth factor or a decay factor? What's the answer? It's a growth factor. What is it? 1.045. Use your equation to determine how much it's going to cost in 5 years. So everybody goes C equals 32,000 times 1.045 raised to the 5th power. Everybody go 32,000, parenthesis, 1.045, close it, raise it to the 5th, hit enter. This is money. You have to have a dollar sign. $39,877.82, and that's your answer. Okay, now let's graph it. I'm not going to use their graph because it's just a quadrant 1 graph. Okay, 32,000. Let's just do this. Let's just go 10, 20, and 30. And you can even do like middle tick marks and not label them. Okay, and we're going to say cost in thousands, and over here we're going to put years, and we're going to go 1 and we're going to go 2, and we remember that this is not linear, it's exponential decay. Okay, so initially 32,000, so it's a little bit above that 30. Okay, after 5 years it's about, oh, it's increasing, silly me, this is exponential growth, so this is going to be, sorry, this is going to be 40, and this is going to be 50. That's okay. Let's just go up higher. So after 5 years, it's almost 40,000. So it's going to go like this, up and up and up and up, and eventually it's going to go up like that. Exponential growth. Who says gotcha? Let's see. Up high. Hi.